All right, welcome back to another video. We're rounding out perhaps the middle to the end of the BFD topic on the JNCIE-SP. So let's go ahead and move on to the next example. Yesterday we finished the first example. It was configuring BFD on internal BGP peer sessions. So now we're going to be understanding BFD authentication for BGP and then configuring BFD authentication. So last time we realized that we actually submitted a documentation downvote because graceful restart was actually enabled by default on all of the devices, and having graceful restart enabled at the same time BFD enabled is something that's not recommended, and it's said to be counterproductive because the features you get through graceful restart are not compatible with the features you get through BFD. If you enable them at the same time, you know, it's like driving a car with your emergency brake on. You're not meant to have it on when you drive your car. So you can see I just did some investigative work. Real easy to find out how to do it. The command is just, oh, and I actually don't see the command on here. There is an issue sometimes where it doesn't keep your most recent commit and it just goes to the previous one. So that might have actually happened, but I guess there's a good news, and that's, it looks like if you just have a superfluous commit, you just change the description before you just say like description done with lab, and then you come back to the next day, it'll just roll back that one description and you'll be better off. So looks like I encountered that same bug, but the bug really didn't affect me that much because it only, because I did the disabling of graceful restart in one commit, and that's the commit that was rolled back, because you can see graceful restart is enabled, but disabling that is really easy. I wonder if it's still in my buffer even. No. So I'm going to disable that again on all of them and then proceed on to the next exercise. So yep, it looks like BFD, here we go. So graceful restart is disabled here, but on these, it looks like it never got on there. It was either rolled back or there was I kind of expected that I disabled it, but it turns out I did not. But I think it's more likely that this is that error where it rolls back the last commit you did. But if that's the case, that's actually really good news, because then I can just make a superfluous commit when I'm done for the day, and then if I encounter that error the next time I boot up, it'll just roll back that superfluous commit, and it won't be like rolling it back to the next exercise. All right, so moving on. So the next part, we did all those verification steps, so we're going to be understanding BFD authentication for BGP. Bidirectional forwarding detection protocol, BFD, enables rapid detection of communication failures between adjacent systems. By default, authentication for BFD sessions is disabled. However, when you run BFD over network layer protocols, the risk of service attacks can be significant. We strongly recommend using authentication if you are running BFD over multiple hops or through insecure tunnels. Beginning with Junos OS release 9.6, Junos OS supports authentication for BFD sessions running over BGP. BFD authentication is not supported on MPLS OAM sessions. BFD authentication is only supported in the Canada and United States version of the OS image, okay, and is not available in the export version. That's interesting. I don't understand that. They must have like their own protocol, or I mean, I'm sure if this is serious enough to warrant widespread use in Canada and the United States, you'd think other countries would have their own solution for it or something. That's interesting. It might be something fun to learn about. What have other countries put in place of BFD on their Juniper gear to have those same security problems alleviated? You authenticate BFD sessions by specifying an authentication algorithm and keychain, and then associating that configuration information with a security authentication keychain using the security name. The following sections describe the supported authentication algorithms, security keychains, and level of authentication that can be configured. BFD authentication algorithms. Junos OS supports the following algorithms for BFD authentication. Simple password, plain text password. 1 to 16 bytes of plain text are used to authenticate the BFD session. One or more passwords can be configured. This method is the least secure and should only be used when BFD sessions are not subject to packet interception. Keyed MD5. Keyed message digest 5 hash algorithm for sessions with transmit and receive intervals greater than 10 milliseconds. To authenticate the BFD session, keyed MD5 uses one or more secret keys generated by the algorithm and a sequence number that is updated periodically. With this method, packets are accepted at the receiving end of the session if one of the keys matches and the sequence number is greater than or equal to the last sequence number received. Although more secure than a simple password, this method is vulnerable to replay attacks. Increasing the rate at which the sequence number is updated can reduce this risk. And replay attacks, I believe those were mentioned on other kinds of exams. I think what they're just saying is that you can reuse, like if you get it, here we go. So a replay attack, also known as a playback attack, is a form of network attack in which a valid data transmission is maliciously or fraudulently repeated or delayed. This is carried out either by the originator or by an adversary who intercepts the data and retransmits it, possibly as part of a masquerade attack by IP packet substitution. This is one of the lower tier versions of a man-in-the-middle attack. Another way of describing such an attack is an attack on a security protocol using replay of messages from a different context into the intended or original and expected context, thereby fooling the honest participants into thinking they have successfully completed the protocol run. Okay, so without even knowing what the password is, you can just take the section of the message that has that authentication and use it for something else, I believe is what this is getting at. So suppose Alice wants to prove her identity to Bob. Bob requests her password as proof of identity, which Alice dutifully provides, possibly after some transformation like a hash function. Meanwhile, Eve is eavesdropping on the conversation and she keeps the password or the hash. After the exchange is over, Eve, posing as Alice, connects to Bob. When asked for proof of identity, Eve sends Alice's password or hash read from the last session, which Bob accepts, thus granting Eve access. Okay, so it's probably simpler. It seems simpler than I thought. It's almost kind of like similar to the plain text. It's just you can get in with the MD5. Oh, okay. So yeah, it seems like it's basically the same as simple password plain text, but instead of using a password, you're using a randomly generated MD5 hash. But the thing is, it's still basically a plain text password. It's just one that was randomly generated, not one that a user created, so it can be intercepted and reused. All right, let's take a look at the next one. Meticulous keyed MD5. Meticulous keyed message digest 5 hash algorithm. This method works in the same manner as keyed MD5, but the sequence number is updated with every packet. Although more secure than keyed MD5 and simple passwords, this method might take additional time to authenticate the session. Okay, so keyed SHA-1, keyed secure hash algorithm 1 for sessions with transmit and receive intervals greater than 100 milliseconds. To authenticate the BFD session, keyed SHA uses one or more secret keys generated by the algorithm and a sequence number that is updated periodically. The key is not carried within the packets. With this method, keys are accepted at the receiving end of the session if one of the keys matches and the sequence number is greater than the last sequence number received. Meticulous keyed SHA-1. Meticulous keyed secure hash algorithm 1. This method works in the same manner as keyed SHA, but the sequence number is updated with every packet. Although more secure than keyed SHA and simple passwords, this method might take additional time to authenticate the session. Note, nonstop active routing, NSR, is not supported with meticulous keyed MD5 and meticulous keyed SHA-1 authentication algorithms. BFD sessions using these algorithms might go down after a switchover. Okay. All right, so almost to the example, just one last section to read. Security authentication keychains. The security authentication keychain defines the authentication attributes used for authentication key updates. When the security authentication keychain is configured and associated with a protocol through the keychain name, authentication key updates can occur without interrupting routing and signaling protocols. The authentication keychain contains one or more keychains. Each keychain contains one or more keys. Each key holds the secret data and the time at which the key becomes valid. The algorithm and keychain must be configured on both ends of the BFD session, and they must match. Any mismatch in configuration prevents the BFD session from being created. BFD allows multiple clients per session, and each client can have its own keychain and algorithm defined. To avoid confusion, we recommend specifying only one security authentication keychain. Strict versus loose authentication. By default, strict authentication is enabled and authentication is checked at both ends of the BFD session. Optionally, to smooth migration from non-authenticated sessions to authenticated sessions, you can configure loose checking. When loose checking is configured, packets are accepted without authentication being checked at each end of the session. This feature is intended for transitional periods only. All right, yeah, I'm not really sure what all that means, but hopefully on the test it won't get too complicated if they even ask for authentication at all. But it is the IE, so I guess anything's fair game if it's in the curriculum, and from what I understand, even if it's not in the curriculum. All right, so configuring BFD authentication for BGP. Beginning with Junos OS release 9.5, you can configure authentication for BFD sessions running over BGP. Only 3 steps are needed to configure authentication on a BFD session. Specify the BFD authentication algorithm for the BGP protocol, associate the authentication keychain with the BGP protocol, configure the related security authentication keychain. The following sections provide instructions for configuring and viewing BFD bidirectional forwarding detection authentication on BGP border gateway protocol. All right, so now we got to configure the actual authentication. So it looks like it's just using the same lab setup from before, which is really good. So configuring BFD authentication parameters. BFD authentication can be configured for the entire BGP protocol or for a specific BGP group, neighbor, or routing instance. So, all right, time to configure. So they're not saying which one to do it on. I mean, I'm assuming you've got to do it on both sides. So let's just do it on the connection between A and B. So here it'll be on GE001, and then here it'll be on GE000. But unfortunately, well, Actually, no, this is gonna work. So, all right, configure private, edit protocols, BGP, show pipe display set relative. So it looks like they kind of abandoned their example from above and they're just kind of showing it just on one device without an associated topology, but that's fine. We'll just, instead of using their BGP-GR1 BGP group, we'll just be using the internal peers one. It looks like they're both going to be IBGP groups, so it's really not going to be an issue either way. Okay, so first step, edit group internal peers, show pipe display set relative. And now we're going to need to, oh, and this is actually going to be one level up. Or actually, no, it's not. Well, yeah, it's going to be outside of the group. But you can do it as it's set up here. You can do it for the whole group, just for a neighbor, or just a routing instance, or the whole BGP protocol. Here, we're actually going to do it for the whole BGP protocol, but of course, we don't have to do it that way. And I'll show you that with the question marks. So set BFD live list detection authentication. Sure enough, we've got it here. So authentication options, and here's all our options. But if I go into edit group, and then the internal peers, now I can also do set BFD liveness detection. And I've got authentication here as well. And likewise, if I go into, oh, and I always like to do relative. So edit neighbor, and then 192.163. Here as well, I've got set BFD liveness detection authentication. So put it wherever you want. This one, we're going to put it to apply to the whole BGP protocol on this device. So set BFD liveness detection authentication. Take a look at the options. We've got loose check, keychain, algorithm. We're going to go with algorithm. And let's take a look at the help menu, just algorithm name. And then here's all our options. We've got meticulous, which means it's going to have each message sent. It's going to be assigned a number, so you can see if, oh, you know, Bob authenticated at number 2, but Bob didn't unauthenticate, and now Mary was listening in, stole Bob's key, and now we've got a number 3 authentication, but number 2 authentication didn't finish yet. So there's obviously something very strange going on. So, but they're going to go with keyed. They're not going to go with meticulous. And you need to, it's recommended that you disable NSR if you're going with meticulous. So let's edit the group. And, oh, it looks like they're going to add it to multiple, oh, okay, I see. I see. So they're just showing you here, just as we did there, that it can be applied to the whole protocol. It can be applied to just the group, or it can be applied to just the neighbor. So this is really not kind of an example showing you how to actually apply it in a topology. It's just showing you what's available. So nonstop active routing is not supported with meticulous keyed MD5 and meticulous keyed SHA-1 authentication algorithms. BFD sessions using these algorithms might go down after a switchover. Supply the keychain to be used to associate BFD sessions on BGP with the unique security authentication on keychain attributes. So this is one thing that's going to be kind of interesting because router B has 2 neighbors, so I won't be able to do it for the whole BGP protocol because I'm not planning to configure router C, but I can certainly do that on router A. So I'll proceed with that. The next part I need to set up is the keychain. So I'll do that for the whole protocol. So set BFD liveness detection, authentication, and now keychain. So keychain name. And we're going to call it BFD BGP, just like in the example. The algorithm and keychain must be configured on both ends of the BFD session, and they must match. Any mismatch in configuration prevents the BFD session from being created. So see very clearly it's not going to be created because it's not set up on B yet. Specify the unique security authentication information for BFD sessions, the matching keychain name as described in step 2, at least one key, a unique integer between 0 and 63. Creating multiple keys allows multiple clients to use the BFD session. The secret data used to allow access to the session. The time at which the authentication key becomes active in the format year, month, date, hour, minute, second. All right, so we're probably going to need to go with a different time than that. So let's go ahead, and this is going to be under security, edit, security, authentication. Oops. Take a look at the help menu. Authentication, key, chains. And then we got keychain. And then, oh, it doesn't save the one that we created before. I mean, it hasn't been committed, so that might be why, but on the test, it's just good to know sometimes because you might be relying on that being saved and kind of being a hint, but then you might not get that hint. All right, so this is going to be the actual key. So now the start time is going to be here. And we're going to need to choose a start time that is relevant. So unfortunately, so I'll need to do a run show system uptime. And now I'll need to pick a start time that is relevant. It's going to be 2020 0409.11. Let's go with kind of surprised. Oh, that's when it booted. So this is at 39, which I'm kind of surprised. It's not matching up with my time here on 47, but let's go with about 5 minutes later, 45, 00. Oops. And it's got to be set, not edit. Oops. And the, let's see here. So it's going to be, oh, that's the wrong, okay, got it. So sets, key, 53, secret, start time, and looks like it's saved. Well, I just type it again. Dot 11:45:00. Perfect. And now I can specify loose authentication checking if I am transitioning from non-authenticated sessions to authenticated sessions. So if I already have a BFD session up and running, which of course I do from the last one, we can actually take a look at that on B, show BFD session. Let me just look at them all. I'm going to have 2. Yep, so I've already got that. So I'm going to need to specify loose authentication so that I can persist with that, but just add authentication on top of it without bringing it down. So I'm going to need to do that to the all of BGP. instead of just the group or just the neighbor, which we're going to be doing on B. We're going to be doing it just for the neighbor. All right, so now we kind of got to race against the clock a little and be sure we're hitting that 45-minute start time. But here we're just going to do it for the neighbor. So edit protocols, BGP, and then show pipe display set relative. So yep, we've got two neighbors in the same group, so we're going to have to do it per neighbor. We can't do it per group because we've only got one group. So edit group internal peers. So edit neighbor, and I actually don't remember which one this is. So I'm going to just do a show configuration on this. Run show configuration, pipe display set, pipe match. And okay, so it's going to be the other one since this is not configured there. So we're going to be editing this one. And now we're going to be setting the set, let's see here, set, oops, come on, set BFD liveness detection authentication algorithm. So we're just setting up the algorithm now. And it's going to be keyed SHA-1, secured hashing algorithm. And it's not going to be meticulous. So it's not going to keep track of the order it was sent. Now we're going to be setting up the keychain. So set BFD liveness detection authentication keychain. Oops, authentication keychain. Oh, neighbor. So set BFD liveness detection authentication. Oh, what was I doing? I was doing something very wrong. Oh, okay. Yeah. They didn't have the dash in their documentation. I mean, that's not worth a downvote, I think. Like, believe it or not, I don't downvote every little thing I see, so I'm not going to be downvoting that. All right, so now I got to set the start time, and that's done in security, top, edit, security, edit authentication keychains, keychain, BFD, BGP, set key, and we're going to do show system, run show system uptime, and looks like, oh, I already kind of missed that 45-minute time window, so I'll just set it to like maybe another few minutes from now, and then I can change the other one, and I mean, whenever I commit it, like I can, so I don't really have to rush too much. Of course, I gotta get back to work around 1, but all right, so set key 53, secret, start time. So let's pick a more relevant start time. It's going to be 04/19.11. So that was 46. So let's go with, how about 49. All right, now it's got to be loose. So set protocols, BGP, BFD, liveness. Oh, and this is going to be done per the actual neighbor. So I'm going to need to find that where I put the, let's see here. So where I called out the neighbor, I want to just go back to that real easily, but fortunately it looks like it's not going to be that simple, but I can just do display sets and see where I put it here. Okay, so now I'm at the neighbor level, context menu. So now I just enable loose check since it's already up. All right, and now a run show system uptime. We've got 48. So show pipe display sets. I'm going to need to change this start time here. Oops. Whoops. And let's get on this context menu for both of the devices so we can have a start time that's really relevant. And do a show pipe display set relative. And then do a show system uptime. We can see we're going to miss run show system uptime. You can see we're going to miss that window. We only got 4 seconds, but the good news is we can take that opportunity to go and take a look at how the Wireshark capture is going to change once we do that commit. So let's bring that Wireshark capture up. Let's set this to start time. Let's do a run show system uptime, and then let's do set start time, and then it's going to be 2020-04-09, and then .11 dot, let's do 51:51:00. Okay, and now we'll do the same thing on this one. Okay, and now we've got our Wireshark capture running, hopefully, or not. Wireshark capture didn't run for some reason. Oh, and then here we see, here's that game ending error that I mentioned in a previous video. Sometimes Wireshark just, it doesn't start. You can see obviously it's not started, it's not activated. So it thinks it's activated, but clearly it's not activated. And you can't activate it because of that. So unfortunately, I'm not sure exactly how to get around that yet. Of course, you can always, there's no real cost to deleting and recreating links. So that's, I think, a good first step that I'm going to try here. So okay, it's going to be 1 to 0, and then 1 to 0 like this. All right, so hopefully now that's going to resolve that issue with Wireshark. And nope, you can see it says that it's already starting the capture. So very clearly there's some sort of game ending error with Wireshark. I mean, another thing I can try is I can actually go ahead and commit these. So here I just opened it in my actual Windows. So I didn't have GNS open it. I just opened it using my operating system. But you can see, yeah, there's clearly a pretty big issue with GNS thinking that it's already active and already open, even though very clearly you can see that it's not. So, okay, so I guess one thing I can do is just commit these and then make a must specify both transmit and receive intervals. Configuration checkout failed. Okay. Same thing for both of them. So, and this is under here, okay. Oops. Well, I think this is a good mystery for the next video. Hope you enjoyed it. Hope the next video goes a little bit more smooth. Until then, stay tuned. And thanks for watching.